Hello everyone, welcome to ECA 210 Lab. My name is Parham, I'm your TA for this semester. Today we're gonna go over how to use the equipment in the lab. Okay, first and most used part in the lab, it's prototyping board. It's mounted on the tables. On each station you have the one that consists of 3 big prototyping boards, or you can call it breadboards. They have columns and they have rows. So there are columns that mark with the red and blue on each part, and there's one big row that's up there connected, colored blue and red. These columns, they all connected from the top to bottom. So if you connect anything from to the top right here, it will be connected to the bottom for each of only the columns though. And this big row too, if you connect anything on this side, will you connect on this side? Only on a blue side or a red side. So anything on the red side will be connected to the red side. Anything on the blue side will be connected to the blue side. And we have these 4 set screws, like the screws connectors up here. So if you want to connect a wire to these screws, you strip a piece of wire, the end of a piece of wire, a little longer than usual. You strip it a little longer than usual, and there's a little pinhole in the middle. So you open the screw up, you put the wire through the pinhole, and you then screw it tight down. Same it goes the other ones, just strip the wire a little more, put it through the pinhole, and screw it back down. So these connectors, they use called banana connectors, which I'm showing you in a second. There are this kind of connectors, it's called banana plugs, which we use. You just simply plug it in, and then you plug the other end to the voltage supply, which I will show you in a few seconds. Okay, so you connected the wires to those connectors. Now you want to have a power to this rail. So the only thing you need to do, you just plug the. I chose black as my ground and red as my my voltage. So I just simply plug the black in the top of the column marked blue, and the white, which is connected to my VCC, to the top of the red column. So now I have power all the way down on the blue column, that's the ground, my ground, and I have the VCC all the way down on the red column. But they're not connected to the other sides. They only connect that those columns have power right now. So how the rows go is, the rows in the prototyping board as follows. Every 5 pin in a row, they're connected to each other. Not onto the other side, only every 5 pin on one side. There's a divider in the prototyping board, so that divider divides the 2 sides. The sides are separate, and each prototyping board, they're separate from each other. So these 5 rows, they're connected. These 5 pins, these 5 holes, whatever you want to call them, they're connected to each other, but they're not connected to the one on the bottom or on the top. So for example, I want to add a resistor to this circuit. I have to put the resistor in a way that the two pins are not on the same row. So I will put one here and one here. Then you have to power it up. This is a simple circuit, just a resistor goes through a power, just uses power. So I just take an extra wire, just plug it in this row, this red column, which is my power. Then I plug the other end to the same row as the 1 pin of the resistor, and I take the other piece of wire. I would then connect it to the blue column, which is my ground, and to the other side, to the row that the other side of the resistor is connected. Now we have a complete circuit, just a resistor in series with a power supply. And let's move on to the other equipment in the lab. So first thing you would notice when you get into your stations in the lab, it's this stack of equipments. So from the bottom, the first thing we have on the left side, we have a multimeter, which you can measure voltage, current, inductance, resistance, or capacitance. On the left side of it, we have a dual voltage supply with a fixed 5 volt. So what it is, you have this voltage supply right here. It has a screen. There's one screen here, one screen here, and it has these pins, these holes for banana connectors. You haven't got it yet. We have a connectors in the lab. Looks like this. It's called banana connectors or banana plugs. There are two types. There's a banana to banana, to which both ends is this, or we have a banana. So one end is banana, and the other end are clips like this. So you push this out. Little connector would come out. Then you would connect it to wire or something, to wire or to a component. So we have the banana to banana. Again, this is a banana plug, and we have a banana to a clip connector that is used for the voltmeter and multimeter and voltage supply. So there are 3 set of red and black holes here. So the left side, it's controlled with these 2 knobs. There are 2 knobs here, and there's a monitor. The right side is connected to by right 2 knobs and a monitor, and the center one, which is a fixed 5 volts. So when you come in, your equipment will turn off. So first you want to turn it on. Just push the middle button. It makes a sound and it comes on. Then you want to connect your banana plugs to the appropriate voltage supply that you want. Then if you want a variable voltage supply, you just use the knob to adjust the voltage. It just shows what the voltage is, and there's a little V on the right side of the screen that's lit up. That means you're looking at the voltage. Then after you get to appropriate voltage, you have connected to your banana plug, so black to black, red to red. There's a button on the middle. You would just push that button and it says on top of it. So now you have voltage pipe pumping. So now you have voltage, that circuit is live. And you want to turn it off temporarily, just push it back and it will turn off. If you want to use the fixed 5 volts, so each of the variable ones, it could handle up to 500 milliamps. If you want to use a fixed 5 volts, that could handle up to 1 amps. So you just connect your banana plugs to the center one. So the knobs, for each knobs, the knob on the left would set your voltage. The knob on the right would set your current. So in our case, you usually want to just turn it as clockwise as possible, so it'll be a max current that you can supply. But in some cases, like when you try to fine-tune something to see like up to what current would it work, you would use that, and you could switch between the voltage for the supply to review voltage or current by this little button on the left side of the screen. So when you push it, it would show on the right side the MA milliamp would lit up, and then you measuring milliamps. You push it back, it would go to the voltage. So on the left we have multimeter. So we have a red, black, and we have 2 blues, and we have these buttons right here. So right now the V is lit up. There's a little V here, the low, and it's DC. It says DC under, so direct current, or it has AC option, alternating current. But for our purposes, for now, we're using DC. So you want to measure the voltage, just connect your plugs. Usually use the Blana to clip plugs. So use Blana on one side and the clips on other side. Just connect them to the black and red. So red to red, black to black. Then you put it across your, you put the clips across your circuit, and you make sure that it's the green, the V is lit up, so voltage is lit up. Then you would measure voltage. So to change between different modes, there are two buttons right here. There's this button and this button. It goes circles through different modes. So if you want to measure current, you have to change it so it says milliamp. It will automatically choose between amp and milliamp, so depends on where you connect it. So you want to measure voltage, you do black to black, red to red, and you do across your circuit. You want to measure current, you keep the black there, you take the red out, and you would, if you want to measure the small current in milliamps, you would connect to the first one. First one from right, first blue from right side. If you want to measure current in amps, you would connect to the last one from right side, last blue from right side. It says amp on it. Please do not exceed the maximum current rating on it. It's written underneath each plug. So for the milliamp, it's a 500 milliamps the maximum, and for amp is a 10 amp max. So for current, you just plug it. For example, we're measuring in a milliamps, so we connected the first blue from right, and then you have to break the circuit. So red one goes from where the power comes in, and the black one goes from the point where power goes out. I would show you further in the lab how to do that exactly, but that's how basically it works. So then we have other ones we don't usually use. We don't use the sound. We don't use the offset. For hold is when you push the hold, you would keep the value you had so you can read it. If you like it's bouncy or you want to disconnect it, you want to remember it something, just push that and it holds it. But it's not usually used. Let me show you something. Also, so we have these two right here, set a range. What it does, it changes the decimal point, so it becomes more accurate or less accurate. So you see, you can see there's L2, it says 0.2. Negative is the just not calibrated, but what it is, it says L3 is 0.001. See, you have like 3 decimal points. L4 you have 2 decimal points. See that what it does? The range sets the decimal points. And there's this button right here that just switches between AC, alternating current, and from to DC, direct current, or both. So you have to see which one is lit up in green. And again, these two knobs right here with the up and down arrow would change the modes. So now it's in amps, now it's in ohms. So you measure the what each resistor value is if you don't know the color code. You measure the temperature. You have to look where it goes. There's a one symbol right here on a bottom right, which is the measure diodes. Again, goes back to voltage. So what it does, this just scrolls through it. So the second equipment we see in a lab. Again, you come in, it's off, you just push it, it turns on. On the right side, there's LCR meter. It's inductance, capacitance, and resistance meter, which we don't use because we have the multimeter, which could do that for us. And that's more accurate than this. So on the left side, there's part we use. It's a signal generator. So what the signal generator does, it generates the different signals for us, not just the direct currents. It generates like, these ones could do sine, triangle, square, and PWM. So first thing says function. The function, what it does, it choose between different signals. So function, the first one is a sine wave. There's a view of sine wave. For the first one on the left, there's a view of sine wave. So that's a sine wave. It would generate sine waves. The second one from left, it's a triangle. Then you push it lit up. Push the function, it would move over and lit up. The third one is a square. Again, lit up. And as you push it farther away, it goes to PWM and then turns off. So turns off, it doesn't like do that. It just it does its own function. So you don't want to use that. You want to usually use square or sine wave. So when it's lit up, the sign is lit up, means you have sine wave going on. So then on the screen, you see a number, and next to it you see the what it is in. So right now it says 1.56, but hertz is lit up. So that's in hertz. So this knob would increase or decrease the value. So that's the frequency. It says frequency on the knob, and what it does, it changes the frequency. But if you want to jump, like if you want to go, now it's 6.28, you want to go to 60.28, it would take a long time to turn that knob. So there are two buttons with a left and right arrow underneath that frequency knob. So if you push the right side, it would move a decimal point to the right. So now it's 61.2. If you push it one more time, it's 621. So each time you push that knob, it depends on the right or left, it would move the decimal point to that side. If you keep pushing that, see now it's 6.21, but it's in kilohertz. On the right side of the screen, it says KHZ, so as kilohertz. So the other ones you have here, it's this combination of two knobs. So the left knob, it's the offset knob. So what it does, it adds DC component to your AC sine wave. So it would, if you're looking on an oscilloscope, it would move your sine wave up and down. On the middle, it says on or off. That button, if it's pushed in, it means on, and you have offset. If it's out, it means it's off, and you don't have any offset or any DC component added to your sine or any signal you're generating. On the right side, it says amplitude. What amplitude is, it's how big your signal is. So how far is the top of your signal to how far is the bottom of your signal? That's what actually is how far is your top of your signal to the half point. So how big each part of your for example, sine wave is. So it's amplitude of your sine wave. If you want to see how far is it from the top to the bottom, is double times the amplitude, but you have to calculate that yourself. It doesn't have any writings on it. You measure it with the oscilloscope and you adjust it on the signal generator. So now we have two plugs here. These plugs look different. They use what is called BNC connectors. The connector would look like this. It has a metal part and it has like a hole like that. There are two kinds. There's this one. So we have a wire that has two sides. Is this? They have two BNC connectors, and so one on each side. And there's the one side is BNC, and one side there's this plug. Again, this is like the clip plug thing, so you can clip it on your circuit. So what do you do? So there are two BNC connectors here. So the left one is called TTL, transistor to transistor logic. We're not using that in this lab, or I don't think we will use it ever, but it's useful in a industry, but not for us. and the right button says 50 ohm output. That's what we use. So I'm just going to connect BNC connector. I'm going to show you how you connect your BNC connectors. So you take the BNC connector, you just push it in and you twist it. So there are two buttons on top of it. Each says attenuator negative 20 decibel. So what it does, it would lower the amplitude by negative 20 decibel, each of them. Okay, one of the most useful equipment we have here, it's called oscilloscope. It's a top rack sitting on top of the signal generator. What it does, it shows you your signal. So we have two channels on the oscilloscope. On our oscilloscope that we have, it's channel 1 and channel 2. Channel 1 is marked by color yellow, and channel 2 is marked by color green. So if you could see, on the left side there are BNC connectors. On the left side, on top of it called 1, so it's channel 1. On the right side is called, on top is a 2, channel 2. So right now both channels are on. As you can see, the number 1 and number 2 are both lit up. So if you want to turn it off, just double tap it and it goes off. So you want to turn on the channel, just push the number and it turns on. So when you do so, menu pops up. On the menu, the first option is called coupling. So what it is, again, so the menu pops up right on here. If you can see, there's a menu right there. To get rid of the menu, it says menu on and off on the first top button here. So you push that, menu goes away, push it again, comes up. So the first option is called coupling. Right on here, there's a button next to it. So if you push that, the extra menu pops up. And then you use this top knob, this like tiny knob with like arrow sign on top of it. You use that to scroll through. So the coupling modes you have, it's a DC, AC, and GND. So don't mistake this. This is not direct current. This is not alternating current. This is direct coupling and alternating coupling. So if you direct coupling, you would have a DC component and AC component in your wave that you're viewing on your results. If you use alternate AC coupling, what it does, it would eliminate the DC component of your signal and would only view it as you only have AC component. So DC coupling, you would have AC and DC component. AC coupling, you would only have AC components, and ground coupling, it's based on ground. We're not going to use that. There's a second option, is bandwidth limit option. And to choose each coupling, so you tap on the button next to it, the extra menu pops up. You either can tap it again, you would change it, or you could use a knob with the arrow on top of it. You could scroll through, and you want to choose something, you push it. So second option is a bandwidth limit. We're not going to use that. You could set it on or off and says to tell it up to what bandwidth to show and up to what bandwidth don't show. The third option, it's called probe. So you have different probes available out there for use. Each probes, the probes that you use are different in a futuristic and in a ohmic resistance. So it's called probe. The ones we have in a lab is 10x probe. So you have to scroll through until you get 10x, and push the button. I believe there's a 10x actually. When you use a 10x, you would have appropriate probe. With the one we use in a lab, the ones that it's a BNC2. So it's a BNC on one side, and there's a clips on the other side. That's what we use, called probe. And that's one we have in the lab is 10x. If you have in a wrong setting, you would get wrong results. So you want to make sure you have a right one. The other setting, so if you see there's a flash here, so that's done there. It says there's an arrow pointing down and there's a button next to it. So it says 1 or 2, 1 out of 2. So that means there's a next page. So you push the button next to it, it goes to the next page. It's called voltage division. Should we do course? So voltage per division, it's how you view on a screen. So we just do course. Invert, we don't want to invert the results, and unit is the voltage. So if we go back, there's arrow up. There's one other one I skipped is a digital filter. So you push the button next to it, it goes to another menu. So basically you can filter your results. You can say what you want to take out of your results that you measure from the circuit. But again, we're not going to use this that much in this class. So you can turn it on and off, digital filter, on or off. There's a filter type. You have a what's it called? You have a low pass filter, you have high pass filter, you have band pass filter, and you have notch filter. So you choose between, and you choose upper limit. It says upper limit. You choose what your upper limit is. So we want to get rid of menu. Just push menu on and off. This goes the same for the second channel. Just you push 2, the number 2. It turns on. This comes off. This menu comes on. Same menu, just a different channel. So if you don't have the menu, if you want to pop it up again, just push the number. If you want to turn off the channel, you push the number twice. So menu pops up. The second time you push it, it turns the channel off. So let me start from right side. So you have 2 buttons called single, and other one's called run, stop. So run and stop is usually green. That means it's in a lifetime. You're viewing the signals you're getting in a lifetime. If you push it once, it turns red. It means stop. So now it's paused. So whatever signal you had, it's paused right there. If you push it one more time, it becomes green again. It's running. So you have a signal in lifetime signal. The single one is when you have a burst of signals coming out and you want to capture that without like stopping it manually. So when you push single, it will turn orange and it's ready. So the first signal comes in, you would capture it and we would pause at it. You want to go in a lifetime menu again, just push a run and stop twice and return green. Anytime you run and stop is green, it means it's running on lifetime. So there's a other thing on the right side. It's called trigger menu. So there's a knob, there's a menu, and there's a force. You don't use the force button. You use the menu and the trigger. The menu, when you push it, menu pops up. First option is called mode. The mode is how you want to detect your signal. So trigger is when a signal comes in and you said, oh, how are we going to detect that signal? So it's the functionality is triggered. So first thing is a mode. If you push anytime you want to see it, whatever anything is, there's a button on the right of it on the screen. Just push it and the second menu pops up. So we have an edge trigger mode, we have a pulse trigger, we have a video trigger, we have a pattern trigger, we have an alternate trigger. So edge means when it sees the edge of a signal, it would trigger. Pulse is it has to have both sides of a signal to get triggered. Video is just, I think, is when you do a video. Pattern is a specific pattern. Alternate, it's you can specify what to see. But on this school, I think for everything we do, we use edge trigger. So there's that. Almost everything we do. The source is how it get triggered. So if you are doing a measurement and signal on a circuit, you're probably doing one that's input and one is output. So you want to trigger an input signal, and you want your second signal not be affected by that. So you want to trigger on first the input signal. So but depends. So trigger, the source for the trigger depends what you're doing and how you connect your circuit. But usually we use channel 1 to measure the input signal, and we use channel 2 to measure the output signal, and we usually trigger on channel 1. But to choose it, there's a button next to it. You push it. It's called channel 1, channel 2, external. External is 1/5 and AC line. So what it is, channel 1 is just channel 1. It's the first connector on the left. Channel 2 is a channel 2. It's the second one from the left. And external, it's this connector on the far right bottom. You could connect that to your signal source and set it or anywhere and say, okay, trigger on that. But that's for more advanced classes. In this class, we're not gonna use it. We're usually gonna use channel 1. So moving on, there's the next option is called slope. The slope is where in the signal you wanna get triggered. So it has up arrow, which is rising edge. It has down arrow, which is falling edge, and there is up and down. That's like when it goes up and it goes like both sides. But what we usually use is rising edge. So up arrow is rising edge. These are most useful ones, and down arrow is falling edge. But for this class, we're using rising edge. Sweep mode, we always using in auto mode, how it sweeps through to find out the signal using auto mode. And for the rest of it, we're not really doing anything with it. The knob on top of it, so that was in a menu. It's a trigger, that was menu, trigger menu. So now there's a knob on top of it. What it does, if you can see on the screen, there's an orange line moving up and down. So what it does, it sets the trigger on different sides of a signal. Like you could go lower on a signal or go higher in a signal. When you push it, it would center it. So moving on, help button just gives you like overviews and stuff if you need help. I don't recommend it. It would go through extensive menus and it would take a long time. If you have any questions, just ask me. Utility is to set up like the color, the brightness, again the other functionalities. Display, same thing. You use like brightness, like the quality of the screen. Print, it would kind of take a screenshot, but we don't use that. The best way to save your signal is called save recall. So for example, if I push save recall, this menu comes up. You could plug in your USB right there, your USB flash drive, just plug it in there. And the way of, you could either save a waveform or you can save a picture. Usually we do picture, so just there's a storage. Right now it says waveform. So you push the button on the right and use knob to scroll. It says waveform setups 8 bitmap, 24 bitmap, PNG, and CVS. We usually do PNG, it's the picture form, but you could also save it as a waveform. So you choose PNG. With parametric save, separa save, we don't use that. And if you have I don't have it USB drive plugged, but if you have it plugged, this external would lit up. It says external right here. That will lit up, and then you push the button. It goes to the under menu, and is ask you for a name, and you can save it right there. Get out of the menu, just push this and turn off them. Okay, then we have a default setup. We would get it back to the factory setup. We have other one. It's really useful. It's called measure. So now it's lit up, so it means measuring stuff. If you push it again, it will turn off. Push it again, turn on. So what you want to measure? So first thing, it comes up in the menu. It says source. Right now it says channel 1. So it's measuring. So when you add measures, it would add it on bottom of your screen. Right now, so when you push the measure, right now it says source channel 1, so you would choose stuff from channel 1. Let me just clear the screen. So right now source is channel 1, so it means if you choose to measure anything, you would measure it from channel 1. If you push the menu, it's to change to channel 2 or channel 1. You can only select those two, channel 1 or channel 2. So right now I'm gonna use channel 1. Second one, it says voltage. So it's not voltage, but it's what you want to measure. So if you push the button next to it, the menu pops out. It says Vmax is voltage max, Vmin is minimum voltage, VPP is voltage peak to peak, Vtop is the top voltage you would get, Vbase it's the lowest voltage you would get, Vamplitude it's a voltage from halfway of the signal to the top of the signal. Let's see, Vaverage is average voltage, Vrms is RMS voltage, overshoot it's those are overshoot is like when you do a signal, it's one part goes really high, that's overshoot. Pre-shoot is low, but we're not using. We usually use Vmax, Vmin, and VPP. So, or we could use Vamplitude. This is what we use in the lab. So if you want to select anyone, for example, I want to use V peak to peak, or let's do Vamplitude. So you go on Vamplitude and just push this button, and you would add it on the bottom of the screen. Second one, it says time. You push that. So time is you're measuring time stuff. So period, frequency, rise time, fall time, width, negative width, positive width, negative DOD, positive DOD, delays or phase changes. So what we use usually, it's use frequency to see what frequency we get. For this class especially we use that, and we use phase change. So it says phase A to B or phase A to B, and there's up arrow next to it. It means rising edge, and there's phase A to B falling edge. So it's like down arrow. So if you choose that, the phases, it means the phase change between your channel 1 and channel 2. That's what it means. For now, say we choose frequency. So you go on frequency, push this. Then there's a other option called clear. So when you push that, it will clear everything. So it cleared the screen. So we go down, there's a down arrow on the menu, it says 1 or 2, so there's the next screen available. So we push the button next to that. It says display all, we turn it off. You want to see all of them, it's clustered. Then there's a counter and stuff, we don't really use that, so turn it off. You have a cursor here. The next button on the left of that is a cursor. What the cursor does, you want to like look closely to the part of a waveform, you use that. One of the most full buttons there are in this machine is called auto scale. So when you push that, it automatically scales your signal time-wise and size-wise, so you can see it on the screen. So there's these knobs on top here, and there is a menu. So this menu is to use it. You can zoom, like in part of a signal. You use this button on the right. It's for these two buttons are for time scale. The one that says push to 0. What it does, it means when you push it, it would change the time scale and neutralize it. The bottom on the left side is bigger knob. The bigger knob. What it does when you turn it, you change the time scale. And if you push it, see there's a, now I'm not changing time scale, and you're doing like a time limitation, and like you limit the time and zooming in. But we don't use that, we just use a time scale change. When you turn it, it changes. So each channel has two knobs. They're color coded. Yellow is channel 1, green is channel 2. So the bottom one, it moves the signal up and down. When you turn it, if you can see on the screen, there's a yellow line going up and down. And you push it, it will center it. The top one, it will change the size of the signal. So if you turn that, it will change the size. And you push it, it becomes fine or coarse. When you push it, the changing of the voltage per division. So the setup signal, it would goes in fine or it would go coarse. Basically that's what all is. Now I'm gonna show you how this works. So other thing is that there are numbers. There is one number on the bottom, there is one number on the top. The top one is in milliseconds or microseconds. They're like in a time, some sort of time. So that means that's 1 millisecond per division. So each box on the screen, if you look closely, there are boxes on the screen. Each box, it's 1 millisecond. The other one at the bottom, it says voltage. It's something, it's called channel 1 and channel 2, and it says something voltage per division. Now what it is, it's each box, if you go horizontally, like up and down, each box, it's, for now it says 5 volts, so that means 5 volts per box. And the time goes vertically, so each box, left and right, it's 1 millisecond right now. So let me show you. So we connected the BNC connector to 50 ohm output of the signal generator. So for demo purposes, I'm using the one that has both sides as BNC. So I'm going to use channel 1. I'm going to, again, to plug it in, just you put it on the plug and you turn it. Push it in and turn it. You see now it went crazy. So I'm going to show you the easiest way to fix this so you can see the signal. Just hit auto scale. You wait, and voila. Every time you want to get rid of menu, just push this button. It says menu on and off. So now you have your sine signal. So on voltage on the signal generator, you can see on the screen we have a sine wave right here. If I change it to triangle, it will triangle. Then now it's a square. Now it's like PWM because it's running. Oh, if you see like signal running, just push the trigger. Just push the trigger menu, and it will stop it. Whenever it's running, it means it's not triggered. It's not detecting it, so it's not stopping it. So just push the trigger. So back to sine wave. You change the frequency. See, when you change the frequency, it gets like smaller and bigger, and the number of how many you can fit in the screen changes. So if I change the frequency like dramatically, now it's 4.56 kilohertz. I go down to 453 hertz. See, you only see a line. So that means you have to kind of like zoom out the time, because frequency is in a time thing is. So you have to zoom out. Use this big knob on the top to change your time settings. So you will turn it until you get your signal back. So now I'm going to show you the amplitude. So what this knob does on the signal generator right here, it changes your amplitude. Okay, let's see what the amplitude is right now. So you hit measure. You go source, it says channel 1, because we are on channel 1. You go voltage, and I want to see the amplitude. So you choose the amplitude, select it. Now it came on the side here. I think our probe we use is 1x. Yeah, that's better. The probe we use in the lab is 1x. My mistake from earlier. Actually, the probe is 10x, I think. But whatever. I would clarify that in later videos, and I would clarify that in class. But yeah, probe is 1x. But okay, so if you see like random, like the number for voltage I got was 70 volts. So that's not right. That this only can supply up to like 20 volts. So you mean the probe setting is wrong. So in our case, the probe setting is 1x, what we use in our lab. But there are 10x probes available out there. We're not using, we're using 1x for now. So 10x is for higher voltage measures and for like more accurate stuff. We're not using that, we're just using 1x. So now you can see the it says V amplitude is 7.56 volts. So if I change I turn this knob on the signal generator, it says now in 12 volts. We went up and down. So these two buttons I told you on the top of the output, when you push that, so right now I have 9.4 volts. If I push one of them, see, signal is so small I cannot measure it. So because it would decrease the size by negative 20 decibel. So if I want to see it again, I use this knob. On each channel there is a big knob. I would turn it, so that increases the size of signal. You see, signal is now bigger. What is running? So I push the trigger. Stopped it. See, now it's 935 millivolts. If I push it, the second one in, it gets even smaller, and I have to increase the size again so I can be able to see it. You don't want your signal to go out of a screen, so if it goes out of a screen you cannot measure it, it's inaccurate. You want to fit your signal in a screen and for a couple periods at least. So right now it's 94 millivolts, even smaller. And if I turn them off again, it would go big. You will see lines like this because it's now our setting is too big, so we have to move it back so we can fit the whole signal in a screen. Offset wise, so the offset on the signal generator, what it does, now it's off. If I turn it on, you see it went down. So if I move it, you can see the signal is going up and down because it's adding DC component to signal. We usually don't use that unless it is specified. So usually we want to leave it off. Again, if you want to turn the second channel, just push the number 2. It comes on. There's a green line. Right now nothing is connected. You want to turn it off, double tap it. Okay, let's see. That should be all. And you can see it. I want to increase the size. Now it jumps. If I push it once, see it goes smaller. It goes like much slower. It moving by smaller steps. So that's what it does. And this one, it moves it up and down. So you can see it just goes up. It goes down, but it's not changing any DC component. It's just moving the signal up and down in the oscilloscope. And if you want to center it again, just push it. It's come back to the center. That should be all. If you have any question, ask me. After you're done each time with the lab, you like to turn everything off and disconnect any cables you have connected. Thanks everyone, and have a good day.